All right, so picking back where we left off. So last time we talked about how to do the graphs for sine, cosine, and tangent. This time we will talk about the rest of them. So the rest of them are relatively easier, especially cosecant and secant, but let's take a look. So let's first deal with cotangent. So cotangent, let's start with the angle of 0. Right, so we could have, that could be 1, 0 with the radius of 1. So cotangent, there we go. All right, so cotangent of 0, remember that's the inverse of tangent, so that's going to be, instead of y over x, it's x over y. So it's going to be 1 over 0, which, as we can see, we're going to have undefined, which means that we're going to have a vertical asymptote at x equals 0. So we can just go ahead and write that right there. So x equals 0, vertical asymptote. All right, so we got to keep going. So let's try pi over 2. All right, so if we go to pi over 2, this is going to be, we could say 0, 1, with r being 1. So cotangent of pi over 2 is going to be x over y, which is 0 over 1, which is just 0. So we get our point pi over 2, 0. Let's keep going. Let's go to pi. So at pi, that point's going to be negative 1, 0 with the radius of 1. And again, that's x over y, so negative 1 over 0. All right, once again, we have an undefined point. All right, so that means, right, if we look at our graph, at pi, we have another asymptote, and at pi over 2, we have a point. So now we just got to figure out something else. So we need 5 points, so we can look in between 0 and pi over 2, we got pi over 4, and in between pi and pi over 2, we got 3 pi over 4. So let's just graph pi over 4. Alright, so remember pi over 4 is a 45-degree angle. So for 45, we got 1, 1, square root of 2. Since we're in the first quadrant, right, everything's positive, so we don't need to worry about that. Alright, so we can see that the cotangent of pi over 4 is just going to be 1 over 1, which is 1. So our point is pi over 4, 1. So now we just got to look at 3 pi over 4. So 3 pi over 4 is going to be in the second quadrant. So again, the reflexive angle is going to be pi over 4. So we get 1, 1, square root of 2. We just need to make sure that, excuse me, that the x value is going to be negative, right? Because we're going in the negative direction. So cotangent of 3 pi over 4 is going to be negative 1 over 1, which is negative 1. So we get the point 3 pi over 4, negative 1. And that's what cotangent looks like. Well, you know, I could do a little better than that. And again, it repeats every single time, forever and always. So we can kind of look, right? It's similar to tangent, but it's in the reverse, right? And notice, tangent goes from negative pi over 2 to pi over 2. Cotangent goes from 0 to pi. Don't get those two mixed up. They are not the same at all. So if we go back to our graph, cotangent, so the 5 points, I'm just going to make this a little bigger so I can write smaller. So the first one we said was going to be x equals 0. That's our first asymptote. Then we got pi over 4, 1. We got pi over 2, 0. 3 pi over 4, negative 1. And then the other asymptote is x equals pi. All right. So if you look across, range is probably going to be the easiest one, right? So range just goes from negative infinity to positive infinity. vertical asymptotes. So if we notice this time, right, we had a vertical asymptote at 0. We have one at pi. So we should have one at 2 pi, 3 pi. So it would make sense, right, that we have it every pi. So the way we could write that is, there we go. So x equals pi n, which means that the domain is all x's such that x is not one of those values, right? Just like with the tangent. All right. Y-intercept. Where does it cross the y-axis? It doesn't, because the y-axis is a vertical asymptote. So there actually isn't a y-intercept this time. What about x-intercepts? So it crosses at pi over 2. The next one, so if you notice, this is going from 0 to pi. We're going pi. So this should also be going pi, right? Pi over 2. Next one should be 3 pi over 2, so on and so forth. So if we notice, the x-intercept should just be pi over 2 plus pi n. And if you notice something cool, the vertical asymptotes of the tangent matches the x-intercepts and vice versa, right? Now why might that be? Because if your x value is 0, right? If you have an x-intercept at 0, well, I guess the y value is 0, right? So if you have an x-intercept, the y value is 0, right? So when you flip it, what are you going to end up with? Vertical asymptote. Yeah, so it actually makes sense that those two would be inverses of each other. All right, period. We already saw that it's pi, but again, it should be the exact same thing, the same period as tangent, since they're just inverses of each other. Since tangent is odd, we know cotangent is odd, which means that it is symmetrical with respect to the origin. All right. Lastly, let's talk about cosecant and secant. All right, so cosecant and secant. So let's kind of use that idea of what we just talked about, right? So secant is 1 over sine, which means that when sine is equal to 0, cosecant is going to be undefined. So when is sine equal to 0? What's equal to 0 at 0, at pi, and at 2 pi, which means for cosecant, we actually have vertical asymptotes. All right. So the other one we have, right, when we have that sine is equal to 1, which means that cosecant would also be 1, right? When you flip it, you still get 1. And same thing with negative 1. When sine is negative 1 and you flip it, it's still negative 1. So what it ends up being is, when it's up, it goes up. When it's down, it goes down. And this is cosecant, excuse me. Secant is basically the same thing, right? So the places that it is at 0 is pi over 2, which will be a vertical asymptote. 3 pi over 2, another vertical asymptote. So at 0, it's 1. At pi, it's negative 1. At 2 pi, it's 1. So 1 goes up, negative 1 goes down. And that's what our graph looks like of secant. And it basically came from graphing the cosecant graph. So we can see that the points for cosecant, it's not as important because as long as you know what sine and cosine are, you can definitely get cosecant and secant easily. But if we're going to write the points anyway, for cosecant, right, we start with the asymptote. So it's x equals 0, x equals pi, x equals 2 pi, and then we had pi over 2, 1, 3 pi over 2, negative 1. We'll just do cosecant for now. So we can see that we had asymptotes every pi, right? So that's going to be x equals pi n. So the domain is all x's, where that is not the case. Oh, wait. Yeah, no. Yeah, it was pi n. Good. All right, the range. What's the range? So some of y'all might think all real numbers, but if you notice, right, it never goes between 1, -1 on the range. So the way that we would write that, let's get real small here to make sure to be able to write everything. It goes from -infinity to -1, including -1, up to 1 to infinity. All right. X-intercepts, there aren't any, right? It never hits 0. The y values never hit 0. We just wrote that. Y-intercepts, again, never. All right, we have vertical asymptote at 0, so there isn't any. Period. Again, since sine is 2 pi, its inverse will be 2 pi. Since sine is odd, the inverse will be odd. Since it's symmetric to the origin, it will also be symmetric to the origin. All right, secant. Again, secant's not as important. As long as you know what cosine is, you should be fine there. But if we look at secant, and so the thing with secant is, as long as you know what cosine looks like, you're fine. Some people would rather have this point, right? So go between -pi/2 and 3pi/2. That's fine if you want to do that. It's fine if you don't do that. So just writing out the points. So 5 points, we can have 0, 1. Asymptote at x equals pi/2. We can have pi -1, x equals 3pi/2, and then 2pi/1. All right, again, we can do range, right? Range is going to be the exact same. Pi, -infinity to 1, -1, and then 1 to infinity. Looking at the vertical asymptotes, we see this is happening starting at pi/2 every pi. So x equals pi/2 plus pi n. So all x's where that's not the case. All right, x-intercepts. Again, there aren't any. It never crosses. Y-intercepts. This time there actually is one, right? Because that's 0. We see that the y value is 1, so we get 1. Since the period is 2 pi, this will also be 2 pi. Some of y'all might have that question. Wait, isn't it? I thought everything changes every pi. But if you notice, the entire thing repeats itself every 2 pi, right? This, right, from 0 to pi is not the same as pi to 2 pi, right? One goes up, one goes down. So it doesn't go back up until 2 pi, which is why we say it has a period of 2 pi. Again, since cosine is even, this will be even. Since symmetry is y-axis, this will also be the y-axis. All right, and here is our official table. So you can go ahead, pause the video, take a screenshot, but this is what the actual whole table looks like. And then here's what all the graphs look like. So we need to make sure that we know what the graphs look like, most importantly. All right, so let's do another identity, and then we will use these graphs for some other stuff. So verify the following identities. Sine of -x, tan of -x, plus cosine -x is secant. So first step, remember we draw that line all the way down. Probably easier to start with the left side, so I'll start with the left side. So for sine, what happens to that negative? Remember it's odd, so it comes out. So we have negative sine x. Tangent, what happens to the negative? Again, it comes out because it is odd. Oh goodness. Technology is awful. All right, there we go. And then what about this negative? Since in cosine, cosine's even, it just disappears. So two negatives makes a positive, so we got sine of x, tan of x, plus cosine x. All right, now, what do we do? Well, we could start with the other side, or we could just turn everything into sine and cosine. So we got sine x times, remember tangent is sine over cosine. So that's sine squared x over cosine plus cosine. So we can make this have a common denominator, right? Multiply by cosine over cosine. This will be cosine squared. If we add those two together, we get sine squared x plus cosine squared x over cosine x. Sine squared plus cosine squared is 1. 1 over cosine is secant. And if we look, that's what we wanted. So we're done. All right. So, last thing we got for this section is x goes to pi negative. So what does this mean? So we're using cosecant, and we're saying what happens when x goes to pi minus. So the minus sign means that x is approaching, if I spelled that right, pi from the left. From the left. So as x approaches pi from the left, what happens to cosecant? So we can go back and look at our cosecant graph. So as x approaches pi from the left, you see that the y value is getting closer and closer to infinity, right? So we would just say that cosecant x approaches infinity, and we're done. That's it. That's all that is. What about when it approaches pi over pi plus? So I'm sure you can figure this out, but the plus means that x is approaching pi from the right. So as x approaches pi from the right, what does cosecant approach? What does the y values approach? So once again, we can look at our cosecant as it's coming from the right this time, right? From the right, we see that the y values are going down towards negative infinity. And that's the answer. That's it. All right, so let's look at another one. As x approaches pi over 2 from the left, remember negative is from the left, so what happens to cosecant? So this is pi over 2, right? So as it approaches from the left, you see it actually gets closer and closer to 1. And it ends up is 1, right? When you plug in pi over 2, you actually get 1. So it doesn't just approach 1, it actually is 1. But for the purposes of this question, we would say the answer is just 1. It approaches 1. All right. And then we got pi over 6 from the right. So if we look at this, right, there isn't a pi over 6. Pi over 6 would be somewhere here, but we can see that it's an actual number, right? It's not going off to infinity. There is a number that we could get to. So all we need to do is just figure out what it is. And we can actually do that for all these problems. The only reason why we wouldn't be able to just plug it in, right, wouldn't just be able to figure out what the cosecant is if the cosecant doesn't exist. Then we would need to use our graph. So for instance, for this last one, right, we could have just done, okay, pi over 2, so that's 90 degrees, right? So that's 0, 1. R is 1, right? If we wrote our weird graph that doesn't really exist, we could have this is 0, this is 1, and that's 1. So for this angle, right, what does cosecant approach? Cosecant is hypotenuse over opposite. So cosecant of pi over 2 is 1, so then this just approaches 1. We can do that with this next one too, right? It actually does approach something. That's weird. So let's just figure it out. So pi over 6, we said that's the same as 30 degrees. Remember, across from 30 degrees is 1. Then we got square root of 3 and 2. Those are the sides we have to remember. So cosecant of pi over 6, that's just going to be hypotenuse over adjacent, over opposite, which is just 2. So we see that cosecant of x approaches 2. So let's see why this doesn't work for pi, for instance. So if we looked at pi, if we did the exact same thing for pi, right? So at pi, we got negative 1, 0, right? R is 1. So if we did our weird triangle, this would be negative 1, this would be 0, this would be 1. So we have hypotenuse over opposite, which ends up getting us undefined. So that's really the case when you need to look at, okay, look at the graph. Is it going to negative infinity or positive infinity? And then you can turn it from there. So for these problems, you can always just plug it in. And the only case that it wouldn't be the actual number it is when you get an undefined answer. Then you actually need to look at what the graph is, see if it's positive infinity or negative infinity. All right, I may do a part 2 for this. I think we should have done trigonometry graphs, the first one. But I'm going to see how far along in the video we are. Maybe I'll do a second video. We'll see. But that's pretty good for now. All right.